Okay, you got the first one pretty right. The second one, not right.
Extrapolation.
Closer.
Extrapolation.
So the two math words we're going to talk about today are interpolation and extrapolation.
Extrapolation. I like that word.
Sounds like really complicated.
It's not that bad,
Sounds
really.
like surgery.
It's really not that bad. Okay, so shh, quiet. So what we're going to talk about today is interpolation and extrapolation. All right? So write those two words down. Interpolation, I-N-T-E-R-P-O-L-A-T-I-O-N, and extrapolation, E-X-T-R-A-P-O-L-A-T-I-O-N. So the two key words, or the two key parts of understanding these two words is interpolation has inter, I-N-T-E-R, which means inside. So inter, I-N-T-E-R, means inside. And extrapolation has extra, which means outside. So we're going to talk about what these two things mean. Interpolation, I-N-T-E-R, means inside. Extrapolation, E-X-T-R-A, extra, means outside. So inter means inside, extra means outside. Interpolation and extrapolation. So I'm going to do a really small scatter plot here because you guys did a few yesterday. But I'm going to show you how you can use interpolation and extrapolation, or how it could be used in the real world. So what I did before I was a teacher is I opened and closed stores for Walmart, but I also managed sales trends.
You did what?
I opened and closed stores in the Northwest for Walmart. So every single item that's in a Walmart store has a sales forecast for it. And that essentially boils down to an equation that predicts how well that item is going to sell for the next week, 3 weeks, and then a year. And it boils down to essentially an equation that they're using to chart how many they need to order per store. And that equation has many, many variables that go into it, including like whether or not there's a hurricane in the world. Tyler, turn around. So let's just take a look at a few things here. So let's say that we have, okay, so we're going to do people in store versus cashiers. And so this is going to be for different times of the day. So like maybe in the morning, Walmart is predicting to only have 20 customers in the store. And so they're only going to have 2 cashiers. Later in the day, they're going to have, they're predicting to have 100 people in the store. And so they've staffed themselves with, say, 6 cashiers. Later on in the day, they're predicting to have 400 people in the store. So they've staffed themselves with 10 cashiers. Later on in the same day, they're predicting to have 300 people in the store. So they've staffed themselves with 8 cashiers. And then further on in the day, they don't know how many people they're going to have in the store. It's a question mark.
So stack it with 20 people.
And so they also don't know how many cashiers to stack the store with. So what we're going to do is we're going to use either interpolation or extrapolation to answer the question of how many people we think there are going to be in the store at this time and how many cashiers we should have in the store at that time. So we're going to make a little tiny scatter plot here to answer this question. And this is honestly something I did at Walmart. I used a scatter plot incredibly similar to this in order to figure out how many cashiers to put in there. So if you ever want to blame people when you go to Walmart, if there's not enough cashiers, blame a person who used a scatter plot incorrectly. Right, exactly. The person who did this, their prediction equation was really bad.
We could teach them something.
Sure. So when you do this, now whatever's on top, does this go? Does what's on top go on the x-axis or on the y-axis?
The Y.
Okay, what goes on top goes on the x-axis. So I'm going to label my x-axis people in store. People in store. And what's on bottom goes on the y-axis, cashiers. So I have to be able to go from 20 up to 400. So what should I count by? 20s is going to take me super far out. So I'm going to actually count by 100s. So I'm going to have this be 0. And I'm going to have this go all the way over to 400. And then I'm going to cut this down in the middle at 200. I'm going to call this 100. I'm going to call this 300. And then on my y-axis, I have to go from 2, my highest is 10. So I'm going to count this 1, 2, 3, 4. I'm going to count this by 2s. So down here I've got 0. Again, I'm not putting a break in my y-axis because that's misleading. I'm going to go 2, 4, 6, 8, and then up here is 10. You guys with me so far? So I'm going to plot my points here. So my first point is 20, which is in between 0 and 100, but it's really close to 0. My first point is 22. My next point is 106. And then I've got 410. And then I've got 308. So I've got this nice, neat little scatter plot here. Cool. So now, first thing I want to do is I want to be able to find the equation of the line that fits this. So I need to pick 2 points that I think best represent the line. So should I pick these 2 points here?
No.
Why?
Because it's wrong.
Well, then it's not that they're too close together. Right, there's not equal points above and below. Good, Christina. It also looks a bit too... What? Oh, I'm sorry. I heard Christina say it because she's right next to me. If Juju said it too, I'm sorry. Thank you, Christina and Juju, and anybody else who said it that I didn't hear, because I'm an imperfect person, and I'm sitting here. Anybody who said that, I'm sorry. Juju. Thank you, Juju. Also, it looks like it would be way too steep. So I want to have it be so that I have equal points above and below. So I'd want to go probably for maybe the first and the last point. Maybe. Does that look like right? Because then I'd have 1 point above and 1 point below.
Yeah.
Okay, so I'm going to go here to there and do that. So my first point was 20, 2, and my last point was 300, 8. Now I want to find the slope between these 2 points. So x1, y1, x2, y2. So I'm going to do 8 minus 2 is 6 over 300 minus 20 is 280. 6 divided by 280 is going to be a great big decimal. Where's my robot? Yeah, I did 22.
Why does your, which one are you doing?
Oh, sorry. I should be 410. Thank you. 410. My mistake. Sorry. Thank you. Everybody who corrected me, this should be 8 over 380. Thank you to everybody who corrected me. This should be 8 over 380. No. Should be 8 over 380. So 8 divided by 380. And I'm going to round that to 2 decimal places, so I'm going to call it 0.02. So that's my slope. And then I'm going to pick one of those 2 points. Which point, or which one of those 2 points do you think I should pick? 22, because the numbers are smaller and probably easier to deal with. So I'm going to do 2 equals 0.02 times 20 plus b. So 0.02 times 20 is 0.4. So 2 equals 0.4 plus b. And then I have to subtract 0.4 from both sides. So 1.6 equals b. So my equation of my line is y equals 0.02x plus 1.6. So this is my line of best fit is what it's called. Now, let's say that I get some information in that tells me that I'm going to have, my computer spits out a prediction amount, and my prediction amount tells me I'm going to have 200 people come in at that point in time. And I need to figure out how many cashiers I should schedule. So if I'm going to have 200 people at that point in time, 200 people fits right here. Now, is 200 people inside the data that's already there?
Yes.
Okay. If it's inside the data that's already there, inside, that's called interpolation. Because if it's inside, that's interpolation. Now, I can then use my equation, and I can take 200, which is in the x place, and put it in for x in my equation, and use that to figure out about how many cashiers I should have on shift. So, hold on, Nathan. I'm going to go back to my equation here, and I'm going to go 0.02 times 200 plus 1.6. And I should have 5.6. So if I have 200 people coming in, should I have 5 and then cut a cashier into a piece?
Yeah. Let's just do 6. No.
Let's just do 6, because cutting people in pieces is how you get into jail. So let's do 6 cashiers. Okay? Now, let's say that I'm scheduling for Black Friday, and I know I'm going to have 1,000 people coming in on Black Friday. Now, is 1,000 inside this bit of information, or is it outside? Now, if it's outside, that's extrapolation because it's extra. I can still use my formula here. I'm going to do 0.02 times 1,000 and then add 1.6. So how many cashiers should I have?
21.6. You gotta chop them up.
So 22. So according to my equation, if I have 1,000 people who are going to be coming in, I should have 22 cashiers.
You might want to call it Paul Blart.
Sure. Now this is exactly what I used to do. Like when I worked opening and closing stores for Walmart, there's a program that we used that predicted how many people were going to come into the store based on how many people had come into the store on that day the year before, and then also taking in different factors. And then we created an equation based on that. We used that equation to predict how many cashiers we had to have on staff.
Wait, there's how many actually count how many people come into a store?
Right, so Walmart, like when you work for Walmart, there's what's called a daily report that you get. That daily report will tell you how many people came into the store that day, the year before that, the year before that, the year before that, what the weather was like the year before that, the year before that, the year before that, what the weather's supposed to be like that day, and then uses that and a bunch of other information to predict how many people are supposed to come into the store today. And because it's predicting how many people are supposed to come into the store today, it creates an equation to tell you how many cashiers you should have on staff today. And that equation is similar to this. It's more variables than just y and x. There's about 5 variables that go into it, but it uses an equation to tell you how many cashiers are staffed. I know. So if you go to Walmart and you feel like there's never enough cashiers, blame the equation. But that's what's going on. It's not people just randomly being like,
So if there's not enough cashiers, I can put a use the personnel as a scatter plot.
right. That's exactly it, yeah. Okay.
Self-checkout line.
That's what I do.
So let's take a look at, so I'm going to give you guys an assignment. We're going to work on this a bit tomorrow.
Okay, good.
So don't worry about having to do this tonight, because we're going to look at it a bit tomorrow.
Oh, thank you.
No, it's not really homework. I just want to get it handed out right now.
It's more of like a practice.
Sure. We're going to be talking more about interpolation and extrapolation.
Practice eat that off.
So as far as like lines go, this is where math is used, or this is where linear math is used mostly in real life. So what we're going to be doing, and I just want to explain this assignment, and then tomorrow we'll have a quiz, and then we'll dig into this tomorrow. So you don't have to get this started today. So what's going to happen on this is we have a table, shows the cost of visiting a working ranch for 1 day and night for different numbers of people. So we have a table, number of people. So if it's a horizontal table, the thing that's on top, is that X or is that Y? And the thing that's on bottom, is that X or is that Y? Great. So I'll give you a piece of graph paper tomorrow. You'll have to make a graph of this. Then the second question, does it look like a line? Explain. And I'll ask you to find the slope. What does the slope represent? We're going to talk about that tomorrow. Write an equation. How much would 23 people cost? And then is it interpolation or extrapolation? But you can answer that question right now, is it interpolation or extrapolation, by looking at this. So this goes from 4 to 12. Would 23 be inside this data or outside this data? So that would be extrapolation. So hold on to this for tomorrow, and we'll continue it from there. Have a great day.